Hi guys, welcome to Pepcoding. So in this video, we are going to discuss the next question of the searching and sorting series, that is maximum in the configuration. So in the previous question, we have find the summation of I into, like the summation of this, that is I into AI, right, for all the array elements. Okay, and we found the rearrangement, like we found the arrangement which can give me the maximum value for the summation of I into AI, right? So we had a choice of rearranging the array elements, right? We could have many rearrangements, but here we cannot rearrange the elements. We can only shift one element, like we can only rotate. We can shift one element at a time. Okay. So let's discuss what this question says. Okay. So now suppose this is my array. Okay. This is my array of size 4. So it has 8. It has elements 8, 4, 3, and 2, and n here is equals to 4. So I can have rotations, right? I can have n rotation, but I can only rotate one element at a time, so that I rotate this 2 here, so it becomes 8 2 8 4 3. Okay, now again, if so, this is my 0 rotation, and if I rotate this, now when I have one more rotation, so my array becomes this, like this, that is 3 2 8 4. Now if I again rotate this, first of all, this is my 0 condition where my array is not rotated. This is my rotation 1. This is my rotation 2. This is my rotation 3. When I rotate the 3 times, like after 3 rotation, what will be my array? My array will look like, my array will be 4 3 2 8, right? If I again rotate this array, it becomes again 8 4 3 2, right? So I can have only 4 rotations, like 4 states only, right? So now let's see what will be the summation of, what will be the value of summation of I into ARR of I, right? What will be its value for this? So its value for this S0 will be 8 multiplied by 0, 8. Yeah. So what will be my value for this will be 8 multiplied by 0 plus 4 multiplied by 1 plus 3 multiplied by 2 plus 2 multiplied by 2, which is equal to, 4 plus 6 plus 4, 4 plus 6 plus 4, which is equal to 14, right? Now for this what will be value for this summation? It will be 2 into 0 plus 8 into 1 plus 4 into 2 plus 3 into 3, right? So it will be equal to 8 plus 8 plus 9, which is equals to 25. Now for this rotate, like for S2, when then 2 into 1 plus 8 into 2 plus 4 into 3, which is equals to 2 plus 16 plus 12, which is equal to 30, right? Now for this, it will be like 4 into 0 plus 3 into 1 plus 2 into 2 plus 8 into 3. So it will be equal to 3 plus 4 plus 24, which is equals to 31, right? So this is my maximum sum. Okay, this is my maximum sum. Now, so that I can perform here, so from here I can see I can perform only rotation and find the maximum sum after that rotation, right? Find the value of this summation, and after that n minus 1 summation, like rotations, I can find out the maximum sum, right? Okay, so now let's discuss it more, that how do we have to calculate this, right? So what was my array? 8 4 2. Now let's take another example. Let's make another array. Okay, this has, sorry, this is, it has A, B, C, D and E. Yeah, n is equals to 5. 0, 1, 2, 3, 4. Okay. Now what we have to do, let's see here the rotations. Now what we have to do here, what we have, like, let's say my S0 here, like my summation here will be what? Wait, let me shift this here. Now, yeah. Let's see now. Wait. Let's take another color. Okay. So S0 here will be 0A, 1B, 2C plus 2D plus 3D plus 4E. Right? Okay. So now my S1 will be, S1 is equals to, okay, so now my S1 will be equal to what? 1, S1 will be equal to 0E plus 1A plus 2B plus 3C plus 4D. Right? Now my S2 will be equal to what? 0D plus 1E plus 2A plus 3B plus 4C. Right? S3 will be equal to 0C plus 1D plus 2E plus 3A plus 4B. Right? Now here also S4 will be equal to 0B plus 1C plus 2D plus 3 plus 3 what? Plus 3E plus 4A. Okay. Now again if I rotate this, it will, S5 will be again, it will again have 0A, then again 1B, right? So here there will be only 5 states, like there will be only 5 rotations, right? So from here, as we can see, first of all, my sum for this array is, sum here is equals to A plus B plus C plus D plus E. This is my sum. So from here, as we can see, all the elements in S0, in S1 are now shifted to 1 position, like forward, right? Here the index are increased by 1 right? So all the elements are like shifted to 1 position. So whenever I add my sum to S0, I get S1, some S1 in some manner, right? So from here, let's see. This is my array, this is my sum, this is my S0. Yeah. From here, as we can see, when I add sum to my S0, I get S0 plus sum will be what? A plus 0A will be equal to A. B plus 1B will be equal to 2B, right? C plus 2C will be equal to 3C. D plus 3D will be equal to 4D. And E plus 4A will be equal to 5A. Right? So when my 4 is shifted to fifth position, na, it is not actually shifted to fifth position. It is also increased by 1, but it is not shifted to fifth position. It is actually shifted to 0 position, because this is working in a cyclic manner, right? So if it's working in cyclic manner, so my last element will go to 0th position, right? So this 5 is not equals to 5, it is actually equals to 0, right? So this should be equal to 0 e, है ना? Because when I add S0 plus sum, I somewhat get S1, but there should be some changes, right? That is, I have to reduce this, I have to make it to 0e. So what can I do? I can minus n. N is what? 5 into ARR of n minus 1. That is my E. N minus 1 minus I. I'll tell you why I'm writing I here in next, like in next rotation. Okay. So if I do this, if I subtract this from this answer, I get my S1. Okay. Which it is nearly equal to S1. So now if I subtract this, it is exactly equal to S1, where I have 0E. This is say my 5E, right? So from this, if I minus 5E, so this and this are like like cancel each other, right? Because when my this answer was like this, right? Was because my this answer was what? My this answer was a plus 2b plus 3c plus 4d plus 5e minus 5e, right? So when I cancel both of this, it becomes 0e equals to 0e. So that's why I have to write this condition. So now my formula is what? To find s of I plus 1. Here let's say I is 0. So I have to add s of I to the sum, and I have to minus this, subtract this n into ARR of n minus 1 minus I. Okay? Right? So let's say if I have to calculate S2 now, if I have to calculate S2 now, for S2, let's see, to calculate S2, I have to add sum to S1. So now this is my S1, which is equals to A plus 2B plus 3C plus 4D plus 0E. So if I add sum to this, that is A plus 2B plus 3C plus 4D plus 0E. If I add my sum to this, A plus B plus C plus D plus E, I get 2A plus 3B plus 4C plus 5, sorry, 2A plus 3B plus 4C plus 5D plus E, right? Which is nearly equal to S2. Sorry, which is nearly equals to S2, right? Right? This answer is my nearly equals to S2 now. As you can see here, my S2 is equal to what? 0D. 0D, let's take another color. My S2 is equal to 0D plus 1E plus 2A plus 3B plus 4C. So I have 2A, 3B plus 4C plus 0E. Sorry, 1E. 1E, right? Plus 1E. And I have 5D. So my 5D will be nearly equal to 0. And we know how to make it to 0. So I will be doing what? I will be subtracting n, which is equals to 5, n into ARR of n minus 1, which is 4. 4 minus I is what? I here is equal to 1, because to form S2 my I should be equal to 1, right? So minus 1, so it should be equal to 5 into AR of 4 minus 1, that is AR of 3 is equals to D. So if I do this, it should become equal to 5D. So if this 5D cancel this 5D, so what I get here? I get 1E plus 2A plus 3B plus 4C minus, sorry, plus 0D, right? This become my answer, which is equal to S2, right? So from here we get the formula, that is to calculate S of I plus 1, I have to add the sum to S of I and subtract n into ARR of n minus I minus 1. Okay? This is my formula. So first to calculate this, I will be having S0. I have to first of all calculate S0 and then sum. And then I will be calculating the value for I plus 1 till n minus 1 till n, right? Till n minus 1 using a for loop. Okay? So let's try to code this. Okay, so now we'll be writing the code for our solution. That is, first of all, I will have to calculate S0 and sum. Okay, both are initially equal to 0. First of all, I will be doing what? I will be storing I'll be storing my array length, right, in an variable. Okay, in an variable n. ठीक है? So int n is equals to my ARR dot size. Right? Now let's do what? First of all, calculate sum n S0. Sum plus equal to ARR of I and S of 0 is equal to ARR of I multiplied by I. Okay. Now do what? We have a formula, so we'll be starting from int I is equals to 0, I should be less than n minus 1, I plus plus, and again I have int max, let's suppose initially max is equals to s of 0, and int s of I is equals to initially s of 0. Now my s of I plus 1, let's make a variable. Now my s of I plus 1 will be equal to what? Will be equal to s of I plus sum minus n into arr of n minus 1 minus I, right? Minus I. And now I will be doing what? Now my si plus 1 will be what? Will become my si, right? And I'll check if my SIP1 is greater than my max. So update my max to SIP1. Okay, and do what? And return max. All right. Now let's try to run this. We have calculated sum should be equal to 0. Sum initially and S0 and SI. Okay, SI plus sum minus n into error. All right. Let's try to run this code. There is some error, I guess. Expected max of s is equals to SIP1. SIP1 max is equals to, okay, there should be some semicolon, and let's try to run this again. I'm getting a wrong output. Int I is equals to 0 till n, sum plus equals to, okay, some s of 0 should be plus equals to now. Now let's try to run this. Yes, accepted, and let's try to submit this. Okay, so this was my code for this max sum in the configuration, and I hope I made it clear to you. So I hope you like this video, and if you like this video, please like, share and comment, and thanks for watching.